All right, it is the top of the hour, so I am going to get things kicked off. Welcome, everybody, to the CircleCI 101 webinar. We're going to be talking about how to automate your development process quickly, safely, and at scale. My name is Grant McGillivray, and I am a DevOps customer engineer here at CircleCI. So a little bit about me. Like I said before, my name is Grant. And I'm a DCE here at CircleCI. And what that means is I provide ongoing technical support for some of our largest and most complex customers. I focus especially on our self-hosted version of CircleCI, but I also do a lot of work on the cloud version as well. So I've worked pretty extensively with both platforms. All right, so the agenda. Just going to go over some of the things we're going to talk about today. First, I'm going to give a quick intro to CircleCI, talk a little bit about who we are as a company and what we stand for. Then I'm going to do a product demo. And as part of that, we're going to go over some basic vocabulary, use cases, configuration, and the CircleCI UI, what that looks like and how you use it. Then we're going to go over some of the core features and just a general overview of the platform and what sets us apart from other CI providers. Then we're going to go into some more use cases and additional examples of things that you can do with CircleCI. And then finally, at the end, we'll have a question and answer segment. So if anybody has any questions about anything during the webinar, anything you don't understand, or anything you'd like me to elaborate on, you can feel free to post those questions, and I will get to them at the end here. So let's get into it. All right. So first off, our mission here at CircleCI is to make it as easy as possible to go from idea to delivery. We want to enable users to focus on writing code while we handle integrating, testing, and delivering that code. So just to remove friction from the software development lifecycle. CircleCI was founded in 2011. We now have over 350 employees spread across 5 continents. And like I said, our goal is to help teams build better software faster. We're currently the world's largest shared CI and CD platform, and we're built for the cloud. We have over 1 million builds running every day on our cloud platform. And you can see here some of the businesses that use CircleCI for their products. Lots of names here you probably recognize. We got Facebook, we got Coinbase, Instacart, lots of other big companies that are using CircleCI in their production environments. So where do we sit in the tool chain? So we want to sit right in the middle here. You can see on the left, we have the creation section here, which is your source control, essentially. Right now, we support GitHub and Bitbucket, but in the future, we aim to have full VCS agnosticism, so your code can live anywhere that it wants, but you can still test it with CircleCI. Right now, though, we're limited to GitHub and Bitbucket. And then in here in the middle, we have CircleCI. So that's the orchestration part where you build, test, and deliver your applications. And then over here is where your code goes after it leaves CircleCI. So where it actually runs in this logistic part here. So it could be Docker, could be in Heroku, you could be deploying to AWS or GCP, anywhere that you deploy your code essentially to. So we also take security very, very seriously in our cloud environment. We have a lot of different security measures that we put in place to keep your data safe. Sensitive data is always encrypted. All builds are run in an isolated sandbox, which is destroyed after every use. So there's nothing else that's going to be left behind after a run that could potentially be a security risk. The only thing that's going to persist are the actual logs from the output of that in the console when you're looking at your builds and any artifacts that you generate and upload over the course of the build. We also use encryption over the entire platform, from HTTPS for the website and for authenticating requests to SSH when you're going to actually get into a build container for whatever reason. And because we are tightly integrated with GitHub and Bitbucket, we inherit our permissions model from that, which means that if you use two-factor authentication or SSO or anything like that for securely managing your logins there in your company, then you're automatically going to be protected with that same protection in CircleCI. And as you can see here, we have FedRAMP certification, we're SOC 2 certified, we have AWS GovCloud compatibility. So we meet the security requirements for use by like government agencies and nation states. So we take security in our cloud environment very, very seriously. And if you're interested in learning more, we have some additional links here on this slide. The links will be available to you at the end of the webinar in case you're curious about reading more. And all of this stuff, all of these links pretty much are going to be going to our documentation page. So all of our documentation should be available about things like security. And then this one here, which is just at circleci.com/security. But like I said, these will all be available to you at the end of the webinar. All right. Now we're going to get into the fun stuff. Let's take a look at a product demo, what it actually looks like when you use CircleCI to test something on your product. So I'm going to go here to this tab that I have here, which is a demo project that I set up ahead of the webinar. So this is called CircleCI Demo Python Flask. And before we get into the build, I'm just going to go over some quick things here in terms of the UI that we're looking at. So what we see right here is an overview of all of the jobs that have run in this particular project. Right now, I only have the one because I just have it set up. You'll notice that it failed, but that's okay because it failed in the deploy step here. And since this is just a sample, a demo project that I cloned, I don't want to actually deploy this application. So don't be worried about that failure. That's intentional. I deliberately set it up to fail to deploy. So what we have here is the pipeline that this is part of, the workflow that the pipeline kicked off, and who kicked it off. In this case, it's me. That's my GitHub avatar right there, and the branch that it was on, and the specific commit. So we'll get into some of these terms, like what a pipeline is, what a workflow is, what a job is, a little bit later. But right now, I just wanted to show you this right here. So let's click into this workflow to see a little bit more about what's going on inside it. So in here, we've got a little bit more information available to us. You can see the total duration of this workflow was 1 minute and 43 seconds. That's how long it took to run until it finished. And I ran it 1 day ago. Again, we have the branch and commit information here, as well as the author. So right here, you can see that this workflow consists of 2 jobs, one called build and one called deploy. Let's go into the build job here. So this is an individual job individual job run. And as you can see here, we have just a little bit more information here. The 2 that are most relevant that are new are going to be the queued. This shows how long the build was waiting to get assigned an environment to start building. In this case, it took no time at all. It started right away. And the executor that it ran on, the execution environment. It ran in a Docker medium executor. And if you're saying, I have no idea what that means, don't worry. We're going to get into it a little bit later. Just good to know that it's there. So right here, what we're seeing is the actual output from the build. And as you can see, this job is composed of multiple steps, and the output is split up into all these different steps. Let's click into one of them. We'll just do the checkout code one so you can see what that looks like. So this is the actual output from that step. This is just like the standard output that's piped to the web UI for you to see from your job run. So you can see everything that the build is doing right here. Like I said, this is just the checkout code step. So this is where it's actually cloning the repository. And you can see everything that it's doing here and the output. And if there were any kinds of problems, that's where it'd pop up. And to wit, let's go back and look at the deploy job that did run into a problem so you can see what that looks like. So as you can see here, everything was going great. We got these green circles here showing that everything is all right. And then it ran into a problem. So if you have a failing build, this is what it's going to look like. It will highlight this step in red, and it will tell you exactly what happened when it failed. So as you can see, the reason that it failed here is because authentication failed for get.heroku.com, which is fine because I never set up the authentication intentionally. And you can see that it exited with the status code 128. So this makes it really, really easy to pinpoint where exactly your tests failed and immediately know where to focus your efforts to fix it. So let's take a look really quick at how CircleCI knows what to even do here at a project configuration file. So this is a CircleCI config.yaml file. This is how you actually set up CircleCI to know what to do when you kick off a build. And we're not going to get too into this because we're going to talk about a lot of this stuff later in the webinar, but I think it's just good for you to know what it looks like and that this is how jobs are defined. So we have here the section where it's defining the workflow, which is called build and deploy, or build and deploy here, which consists of two jobs called build and deploy. The jobs are defined here. This is where you actually tell it what tests it's going to run and what environment those tests are going to run in, and the individual steps that take place inside of those jobs. And then there's the deployment job here. So now that that's done, let's head back to the slides. All right, so now we're going to talk a little bit about the configuration hierarchy. So this is where I said we get into it a little bit more. So at the very top of the configuration hierarchy, we have what are called pipelines. A pipeline is a full set of workflows. It can contain one or many workflows, and it coordinates jobs, like I mentioned before, inside the config.yaml file. That is like the main source of truth where CircleCI looks to get all of the information about what exactly you want to do in your job. So underneath pipelines, you have workflows. Workflows are a collection of jobs and the order that they run in. So like I said, you can have one or many per pipeline, and you can have a workflow that consists of a single job, or you could have a workflow that consists of dozens of jobs and complex conditional logic about the order that they run in and when they should run. It can be anything from very, very simple to very, very complex. You can also have multiple workflows that could run simultaneously or only under certain conditions. Then the next step down the hierarchy, we have jobs. So jobs are collections of steps. All steps in a job run in either a single clean container or inside a VM, according to your needs. And every workflow is made up of at least one job, but can also be made up of many, many jobs. And steps are individual executable commands run during the job. So if we go back to our demo repo here, you can see this is one job, the deploy job, and these are all the steps. These are all the individual things that this individual job is doing. And if we go back here, the workflow level, you see the two jobs that make up this workflow. And then if we go back here to the master branch, you can see the pipelines, which consist of this one workflow. And this is, again, the links will be available at the end of the presentation. If you're curious in poking around at our demo project, this is the one that I cloned for this presentation here. All right, now we're going to talk a little bit more about the features available in CircleCI. So one thing that we have that's really, really cool and useful are what are called orbs. So like I mentioned before, everything in CircleCI is configured using YAML. And if you have a lot of different repos in your project or across your org, it can get really difficult to maintain all of those different projects, especially if they need to reuse similar elements of their configuration. So an orb aims to fix that by having it be a reusable package of CircleCI YAML that you can just drop into existing projects and pass parameters into it as needed. So an example that I use all the time is we have a Slack orb. So if a lot of your projects need to alert a Slack channel if they fail or something like that, instead of having to manually write that out and copy and paste this big chunk of code into your YAML file in every single project that needs to be able to alert a Slack channel when something happens, you can just drop the Slack orb into your project instead and pass the appropriate parameters into it for whatever channel you want it to notify. And it will take care of that all for you. And it will be much, much easier to read your configuration file. It'll be much cleaner because you won't have a lot of this reused code over and over again. And it's way easier to maintain because if you make a change to the orb, that will update every project that uses that orb automatically. So instead of needing to go into every single project and update its configuration file, you can do it in one place. And that makes it way, way easier if you have anything that you know you're going to be reusing across many different projects. So this is an example here of what an orb looks like. So what we have is the commands section up here first. Commands are basically parameters that can be passed into your job. And we're going to be talking about parameters a little bit later, so don't stress too much about it. It's just good to know that you can pass information into orbs, and this is what it looks like here. So this is basically, as the description says here, an orb that says hello. And right here, we're defining a command called say hello. The default value is going to be grabbing the CircleCI username, and then the step it's going to run will be hello, and then whatever parameter is passed in. So if nothing is passed in, it's going to grab this default value, which in this case would be the username of whoever is triggering this build. Next up, we have the executors. Executors are defining the runtime environment for setting up and executing jobs. Like I mentioned before, we're going to be talking a little bit more about executors and execution environments later. So don't sweat it too much right now. It's just good to know that you can define one inside an orb and that you can pass parameters in to change what execution environment runs as is necessary. And last but not least, we have jobs. This is exactly like a standard configuration file. You will invoke a job that you want the orb to run. In this case, it will be a job called hello build, and it will execute the step that we defined up here in the command section using the executor that we defined here in the executor section. So this is just a really simple orb that if you were to drop it into your project would essentially build according to, it would build a container using this default executor, and it would say hello and your username, assuming you did nothing else. All right, so here's just a small sample of some of the orbs we have available. We have a ton of these. So there's 3 different categories of orbs. We have CircleCI orbs over here. These are orbs that were actually written by CircleCI, first party. And we integrate with a lot of really common things like AWS, Docker, Google Cloud, Heroku, Slack, like I mentioned, probably the most popular orb, Kubernetes, lots of different things for CircleCI orbs. Then we have partner orbs. These are orbs that are written by CircleCI partners, written in partnership with us, but not by us. And we have a lot more different utilities available for you here according to your needs. Really common ones I see a lot are JFrog, Rollbar, lots of different things that just make it way, way easier to implement into your configuration file, take a lot of the manual work out of it. And then we also have community orbs, which are just written by members of the community and published to the public orb registry. Anybody can write an orb and publish it to the orb registry. We make sure, that they're not doing anything like malicious or anything like that. But if you ever have a need for an orb that you want, you can write your own if you find something is missing here and publish it to the orb registry and hopefully help people out. And you can see here just a general number of the orbs that we have, 55 first party, over 80 partner orbs, and 1,700 and counting. This number is almost certainly already out of date because it's going up all the time. Okay, so resource classes. This is what I was talking about a little bit earlier with the different executors that we have available. So really quick, we have Ubuntu executors available. We have Windows, macOS, and machine VMs for if you need a full virtual machine and not just a container. One thing that's really good to note is that for most of these, you can actually specify a resource class. This will change the amount of resources that are available in your runtime environment so that you can tweak those exactly according to your needs. So this example here is for the Docker executors. And this is going to be the most common type of executor that you're going to use unless you specifically need to use a different type. And these are all of the resource classes available. So as you can see here, the default one, if you do not specify one, it is going to use the medium executor. which gives you 2 virtual CPUs and 4 GB of RAM. We also have a smaller size one here for things that need less resources, maybe like a linter job or something like that, that isn't going to be really resource intensive. You can use a small executor and have it execute faster and use less credits. And then we also have a selection of larger ones here for any project that has additional memory needs or anything. So we have medium plus, large, X large, and then at the highest end, we have 2X large and 2X large plus. These require a manual review to be toggled on, but they are available if you have any project that has really beefy CPU or memory requirements. So every job in a workflow is capable of using a different resource class according to its need. And that's what we have an example of down here. So this is a workflow. And what you're seeing here is one job called test that then fans out into 2 jobs that run in parallel. This one here is using a medium resource class, and this one here is using a small resource class. And the reason for that is because this one here, judging from the name, is just creating a parameterized command. It needs very little resources. So by using the small resource class, it takes less time to spin up and you use fewer credits. So it's a good idea to try and tune your resource classes as tightly as possible so you're always using the smallest executor that you can and still have your builds complete without running out of memory or being CPU bound. All right, so another really useful feature here is parallelization. So when you have, let's say, a test suite, let's say you're using Jest, just as a random example of a test suite, you might have 50 tests that need to run. Without parallelization, you'll be running all of those tests in a single job, one after the other in sequence. And that can take a long time. It's not very efficient. CircleCI actually offers test splitting, which means that you can either manually split the test yourself, or you can use our CLI to dynamically split tests according to their performance and time. And that will mean that all of your tests can run in parallel. And that's much faster. So this is an example here of a job which is running 4 different tests in parallel. So this one job is doing a test suite, which consists of 4 tests. And instead of having to run them all sequentially, it runs them all simultaneously. And that is huge for speeding up tests, especially if you have a test suite that is running a lot of different tests. I've seen people with like hundreds of tests in their test suite, and it makes a huge difference to use parallelization. It's a very powerful tool, and our dynamic test splitting feature makes it really easy to split your tests. And like I said, we have examples here, documentation, lots more. This will all be available to you at the end. Okay, now we're going to get into parameters a little bit more. First, I'm going to take a quick drink of water. So I talked about parameters a little bit earlier, but we're going to get just more into it now. So parameters can be passed into jobs at runtime, and they can be used to set up conditional logic to do different things according to what parameter is being passed in. So this example here that we have is setting up a job where we have a job which is called say hello, and we're defining that it takes parameters and the subject here. So the description is just what this parameter is doing. And then you set a default value, which in this case is world. This can be anything you want. And the type of value that it's expecting, in this case, a string. And then we run this job here where this step here, where we just echo hello, and then whatever parameter is being passed in. And then down here in the config file, you can see we're setting up a workflow, and it consists of 3 different jobs. We're calling the say hello job 3 times, but we're passing in different parameters. So the first time here, we're saying the say hello job, and we're not passing anything in, which means it's going to grab the default value and it will print hello world. In the second one, we are invoking the hello world job, and then we're passing in a subject parameter that we defined up here, in this case, everyone. So this job would say hello everyone. And then finally, again, exact same thing, except this time we're passing in friends for the parameter that we called subject up here. So it's going to say hello friends. And that's just a really simple example of parameters. You can get really, really complex with this by going into having different executors that are being run depending on the parameter that you do, having different jobs, even different workflows depending on which parameter. It's really, really powerful. And we can have here an example of what a config file looks like without parameters and what a config file looks like with parameters. So you can see just how much of a difference it makes. On the left here, we're having to specify 3 different jobs with different versions of Node that are all doing the same thing. The only difference is they're testing multiple Node versions. So this config file is pretty long, not very nice to read, and it's going to be difficult to maintain if you ever want to change those Node versions in the future. Then over here, we have the parameterized version. We're simply defining it once right here, and then we're setting up the parameter, which is the version of Node, and we're passing in this default value here. So instead of having to do 3 separate jobs, we define one job that takes a parameter that corresponds to the Node version, and then we just pass that Node version in at runtime. This both makes it much, much more compact and easier to read your configuration file. It also means that in the future, it's going to be much easier to update it, because instead of having to rewrite the job and delete any old jobs that use old versions of Node or update every individual Node instance, all you have to do is change the parameter that's being passed in, and it'll be future-proof. Okay, so next up here, we're going to be talking a little bit about the CLI. And the CLI is very, very powerful. It can also pass parameters in. And as an example of some of the cool things that the CLI can do, I actually have another demo that I whipped up here for this presentation. So what we have here is another build called CircleCI Demo Context CLI. And it's called that because we are passing in something called contexts, which we're going to get into just a little bit later. But this is just a good example of things that you can do in the API. So we'll go into this one here. This is a run that ran that failed, and this is one where I fixed it. In this case, I did want it to succeed, so we're going to go into the fixed version here. This is a workflow which consists of one job. So just going to go in here and show some of the things that the CLI is capable of doing. So right here, it's grabbing the environment variables that are built in to CircleCI by default, the ones that are just available, installing the CircleCI CLI, configuring it, making sure everything is set up. Then it is going to be listing out contexts. Contexts are essentially just a group of secure environment variables. Like I said, we'll get into a little bit more. But as you can see here, there are no contexts. Then we use the CLI in the build to create a new context called test context. As you can see here, it's redacting this provider section automatically. So the CLI, completely automated, no interaction from me except for kicking off the build, has created a new context. Then we look inside the context to see the environment variables that are inside it, and there are none. We expect it to be empty. Then we create a new environment variable. Again, this is all with the CLI, completely automatic, called test secret, and it automatically redacts the value from the console, so it prevents your secrets from being leaked if anyone accidentally prints it to the terminal. And then we remove it again, just to show that you can do that, and we delete the text context to see that you can do that. So the idea behind this is that it makes it really, really easy for you to like rotate your secrets and things like that, which is a very, very useful thing to be able to do, to automatically rotate that kind of stuff. But that's just one example of the thing that the CircleCI version 2 API can do. It can do all kinds of things that can help extend the functionality beyond what's available just here in the UI. So heading back to the slides. Now we're going to talk a little bit about matrix code. So matrix code is really, really useful if you need to build on multiple different environments. So if you have something that you know needs to be tested on Docker, Ubuntu, and then on Mac OS and Linux, and in this case, also Windows, and it's going to be the same project. Instead of having to define all of those jobs manually, you can define what's known as a matrix, and it will expand that out. So as an example, we have this configuration file here, which is grabbing a list of executors. In this case, this particular image here for the Docker executor, this Ubuntu machine image, so this is a full VM, this macOS Xcode version for the macOS executor, and the CircleCI Windows Orb, which is how you get a Windows executor. And then it's defining a matrix test job. So this takes parameters of OS and subject, and then for the executor, we define here as the parameters.os. So the executor is going to take whatever is passed in as the OS parameter. And then in this workflow here, and then this is what it actually does. It's just saying hello. So we're going to skip to the workflow part here where we define what actually runs. And then under here, we have matrix test. We set up a matrix and we pass in the parameters of Docker, Linux, macOS, and Win/default, which we defined up here in the executor section. And this one very small configuration file spins up all of these different builds automatically using matrix expansion. And because we're passing in multiple different values for subject, it also spins up a build for each one of those in each executor. So it's a really, really powerful tool for kicking off multiple builds with very little configuration work required on your end. So that just makes it much easier, again, to read and maintain. That's what we're all about. We want it to be efficient, and we want to remove as much work as possible for you to get building and testing in any environment that you need. And we have, again, a link down here to see this particular project if you're curious about looking at this configuration file further, try and pick it apart. We have that available. It's a public repo. Like I said, links should be available after the webinar. All right, secrets, rotations, and contexts. So like I mentioned before, contexts can be basically any collection of environment variables, but usually people use them for secure environment variables like tokens and things like that, because contexts can be secured. And what that means is you can limit who is able to use a context. So let's say you only want a certain group of employees to be able to deploy to production. You could create a context that contains your deployment key, and then you can actually limit which groups of users are allowed to use that context. So if you have groups set up in GitHub and you have users that are defined to, let's just call it a deployment group that's allowed to deploy, you could set that context to only be available to those groups of users. So if anyone else attempted to run a build that was using your deployment context, it would automatically be rejected because they don't have the authorization to do that. So contexts are really, really useful at ensuring that certain sensitive environment variables are only available to the people for whom they should be available. And like I mentioned earlier, the example project that I showed, we have Secret, which is available with the CLI. So like I said, CLI can be used for all kinds of things, but we have that secrets rotation demo to show off how easy it is to rotate out your tokens, your keys as necessary, or according to your org's security requirements. Okay, now we're going to get a little bit into some other use cases for CircleCI. So this is just going to be some places that you can use CircleCI to deploy to. We can deploy to a Kubernetes cluster. You can deploy directly to ECS, GKE, to EKS, pretty much anywhere that you might want to deploy, although we integrate really, really tightly with AWS and GCP. So I've recently been doing a lot of Kubernetes deployment, and it makes it really, really easy. And we have a very good and thorough configuration cookbook here, which you can look at to see different places you can deploy to, what you need to do to get that set up, and some snippets of code that might make it easier, or orbs that are available to make it easier for you to integrate with whatever tool that you need to use, whatever you're using to manage Kubernetes. And you can also deploy iOS applications directly from CircleCI. We have another great guide here for deploying iOS applications. You can deploy directly to the App Store, or you can deploy to Firebase or the Visual Studio App Center according to your needs. And we also support Fastlane and code signing directly from your CircleCI environment. So this is an article here that will be available to you in our documentation that just goes over everything you need to know if you're doing mobile development on iOS. And this is some example projects and tutorials that we have. So this was a very quick, sort of very high level overview of what CircleCI is and how it works. If you want to get more into the nitty gritty, we have tutorials here for how to build sample projects. This Linux project tutorial right up here is actually going to use the same repo that I used for the demo, the CircleCI demo Python Flask one. So if you want to poke around with that on your own, you can get that here. We also have ones for other executors if you know you're going to be doing iOS or Android or Windows building. And then we have a bunch of different language specific guides to get you started. If you do a lot of building in a specific language or in a specific framework here, you can grab one of these and you'll be off to the races. You can play around with it, get a feel for how things work, run your own builds and see what happens. And last but not least, this is another selection of links that's going to be helpful for you here. Where to sign up, simple hello world build, how to migrate off of other CircleCI, not CircleCI, how to migrate off of other CI providers and come over to CircleCI, more tutorials, handy configuration reference, and testimonials. Okay, so that is about the end of the presentation. So if anybody has any questions, now would be the time to ask them. And I see there's already some in there. So I'm going to go through and take a look at these now. All right, so we are going to start out here with the first one that I have. It's good to see that CircleCI also displays the executed script along with its output. That would help a lot during troubleshooting. Yes, we have, so I'm going to go back and show that again really quick. If we go into the, oh, no, sorry, that's the wrong area. That's the project settings. Go into this build job here, configuration file. So what we have here is the configuration file. We have both the source and the compiled version. So you can see not only the human written version of the CircleCI configuration file that your project is using, you can also see what it's compiled to at runtime, what our system got and how it implemented that. So here's the compiled version. You'll notice that this expands out a fair bit. It's a lot longer. This can be useful if what you wrote did not actually do what you thought. You can see the compiled version. Okay, so I'm going to mark that one as done. Head back to the slides and go to the next one. Are orbs defined in Git repositories or directly in CircleCI? If in a Git repo, does it support private repos? Yes, they are defined in a Git repository. When you write an orb, part of that process is going to be creating a Git repository and pushing to that to create an orb, essentially. And our orb registry will pick up on that. As for if it supports private repos, yes, as of very, very recently. This was a big ask for a long time, but we do have private orbs now. It is possible to create an orb that is only going to be available for people in your organization. The process for doing that is a little bit different than with a public orb, but it is available. It is something that you can do. So we have a lot of customers that will write orbs that contain things that are not going to be useful for the general public, but are really useful for their organization. Maybe they contain certain secure environment variables are something that they don't want to have public necessarily. It's a really common use for Git repository or private orbs rather. So yes, definitely able to do that. I'm going to mark that one as done and head on to the next one. Can we define orbs to be reusable at different levels, i.e. as a reusable step, reusable job, or reusable workflow? Absolutely. Yes, you can. You can define, so this is another thing where parameters come in really handy. You could define whole workflows. You could define individual jobs. You could define individual steps, and then you could call those as necessary by passing in the appropriate parameters. So if you're going to run a job on CircleCI, that job has to exist inside a workflow, even if that workflow consists of only that job. So technically, everything is going to be a workflow, at least one workflow that contains at least one job that contains at least one step, right? But you can absolutely write multiple different jobs and multiple different workflows that can only execute under certain conditions. And then you can dictate those conditions with parameters. So yes, you can basically have any type of workflow, any number of steps or jobs that you want to run, and any kind of condition that you want those to run under, as long as you can specify that condition by passing in parameters. I hope that was clear. If not, feel free to ask any clarifying or follow-up questions. I am an open book, and we still have 19 minutes. So anybody has anything, now's the time. The last question that I have here is still open. Can we have CircleCI server self-hosted in our company? Does it have the same features as the version on the cloud? Good question. The answer is yes and no. Yes, you can have a self-hosted server version that's hosted on premises. We do have that. That's actually what I spend most of my time supporting. I do a lot of my work on the self-hosted version. It is not at parity with cloud yet. It does not have all the features of CircleCI Cloud. Although we are currently in the process of actually developing Server 3.0. We've been on 2.0 for a long time. Server 3.0 is right around the corner. We're totally switching up how everything runs on the back end. We're going to be having it run in the same Kubernetes style backend as our cloud product does, and it's going to bring it much, much closer to feature parity. So with 3.0, you will get things that are currently missing from the on-premises version, like orbs and parameters and stuff like that. That's not available in server right now. But when 3.0 comes out, which is going to be hopefully safe harbor, no promises here, but hopefully very, very soon, because I've been doing a lot of work on it, it will come much closer. And the goal is to have full feature parity before too long. So I hope that answers your question. Yes, we do have a self-hosted version. If I were you, I would probably wait until 3.0 is available because that's just going to be much more feature rich than if you were to sign up for 2.0 right now and then have to translate or migrate everything into 3.0. But I don't think you'll have to wait very long. Okay, next question. Is there any integration with Kubernetes cluster as a custom resource definition? I'm not 100% sure about that one. I know that you can set up, like you can deploy a Kubernetes cluster from CircleCI. You can use like so I've used most of my Kubernetes experience has been in EKS. So I'm going to be talking about this through a very AWS EKS focused lens. So hopefully that's helpful. But I know you can install like EKS CTL into your CircleCI environment, and you can actually do things like deploying new clusters, installing things into those clusters, interacting with those clusters. You can do all of that from CircleCI if you want. So I would think, I'm not 100% sure if you can do custom resource definitions, just because I haven't poked around with that much myself. My intuition would be to say probably, but I can't say 100% certain. I do know, though, that you can do a lot of the things that you would need to do to manage a Kubernetes cluster directly from CircleCI. Okay, so next question here. How can we automate the workflows? Specific configuration. So I guess when you say automate workflows, do you mean have them run automatically, like on a schedule, or are you looking to have workflows that do different things in different situations? I guess it depends on what kind of automation. So if you want to, for instance, have a workflow that runs automatically, you can do that. We do support cron jobs, so you can set up a cron that will run like a nightly workflow or something like that every night automatically. And we have documentation on that you can find. It's not too difficult to set up. If you're talking about how to make workflows sort of change depending on the parameters that you pass in, that's going to be mostly to do with how you initially write the configuration file. So if you want, as an example, to have the executor change depending on what parameter you pass in. So say you sometimes want this workflow to run in a Docker executor when you're building an app for one platform, and a macOS executor when you're running an app for a different platform. You would write in your configuration file, you would set up a parameter, call it whatever you want, but probably something like OS, and then have it expect a string, and then pass that through in at runtime, basically. So when the user triggers a build, they would specify that they were passing in the macOS parameter in their configuration file, or in like maybe via a tag. You could tag the commit, and CircleCI would pick up on this commit and goes, oh, okay, if this commit is tagged with macOS, I should pass the value macOS in as the OS parameter, and then it would spin up a macOS executor. And like I said, we get, you can do really, really super granular things with automation and parameters and conditional logic and what runs under what circumstances. And all of that you can get into in pretty detail in our documentation. But if you have any specific questions, lay them on me. So hopefully that was helpful. All right, next question. How do you manage a user or organization's namespace in CircleCI? In this case, we are a big company that has many different orgs/departments. So in this case, usually the way that we do that is, so if you have different GitHub orgs, you can actually have what we call piggybacking, which is where if you sign up on like your main org or a main org, you can then have different orgs that are in your company piggyback off that same subscription. But the general gist is that CircleCI inherits all of the permissions from your VCS. So if you have like teams set up in GitHub, GitHub admins, that kind of stuff, that'll all be inherited by CircleCI. So if you have users that are part of a certain team that manages a certain application and does not have access to the repositories for other applications, they would not be able to access those repositories in CircleCI. We would inherit the user's permissions from GitHub, and we would only surface those repositories that they already have access to. You would not be able to trigger a build in any repository that they can't actually see in GitHub. So that's generally how we handle access and organization permissions right now. As part of VCS agnosticism, when we eventually make it so that you can use any VCS and we're not strictly reliant on GitHub or Bitbucket, we are going to be implementing our own permission system, but that is a ways off. It's probably not going to be anytime super soon. It's a little hard to say, but it's going to be a big undertaking. But for right now, we just mirror everything exactly as you have it in GitHub or in Bitbucket. Oh, something I just thought of that I should mention actually is that we do support GitHub Enterprise, but GitHub Enterprise is currently only supported in our self-hosted server version. So if you use GitHub Enterprise, you will need to get the self-hosted version. The cloud platform cannot currently hook in to GitHub Enterprise, although that is in the roadmap to change in the future. Okay. How many types of webhooks does CircleCI support currently? Only from GitHub and Bitbucket now. Yes, right now we only support webhooks coming from GitHub and Bitbucket. We are not able to pick up on webhooks from any other VCS provider. Only GitHub and Bitbucket webhooks will actually trigger builds. Barring things that are manually triggered, like a user clicking the rerun build button or somebody triggering a build directly from the API, and we can pick up on that. But when it comes to incoming webhooks from VCSs, currently it is only GitHub and Bitbucket. Although, like I mentioned, we do support the enterprise versions of those, just only on the server platform. Okay, so I have run out of open questions. I will wait a little bit more and see if any other questions come in. Oh, there we go. Any orb support for OpenShift? I'm not 100% certain. Let's check the orb slide that we had here. I'll just back it up real quick to there. This is a very small selection, but I almost feel like I might have seen OpenShift in here. Okay, doesn't look like I did. I thought I did. I must have been mistaken. I'm not 100% sure off the top of my head, but I can search the orb registry really quick and get a answer right now. Let me just pull that up. And you can also search the orb registry yourself too. If there's, yes, we do have an OpenShift orb. We have a couple of them. They're all community. Most of them are community orbs, but there is actually a CircleCI orb for working with Red Hat OpenShift. So there you go. We do have OpenShift support via an orb. Okay. What are the points that are covered when while planning phase of operation, or sorry, phase of automation? I think I might need a little bit more information about this one. When you say phase of automation, what specifically are you referring to? Might need a little bit more clarification there. Okay, any examples for automated testing? Do we have labels like TFS, Team Foundation Server? I'm not familiar with TFS, so I can't answer that one per se, just because I haven't used TFS before. We do, again, I don't know if this is exactly what you're looking for, but we do pick up on labels that are coming from GitHub. So if you like tag a commit or put a label on your commit, we can pick up on that and do different things according to that. But when you say examples for automated testing, I guess I sort of want to clarify what you mean by automated testing. Like, are you thinking having a machine user kicking off builds? Are you thinking about having like a scheduled cron job kicking off builds? Or are you thinking something along the lines of like a build that is capable of triggering other builds? I guess I just want a little bit more information about the kind of automated testing that you want some more information on. I will say that all of those things are possible. All right, licensing model, per user, per CPU, or per what? So for cloud, it is by credits. So those are basically like minutes of build time. Larger executors use more credits because they cost more to run because they use more resources. So on cloud, what you do basically is you will purchase a given number of credits, and then you'll use those credits. And we try to, if you were to sign up, we would do an annual sort of credit cadence where, like if your org was to sign up, you would get a certain number of credits a year. We would do our best to estimate how much usage you would need. And then, of course, if you find yourself running low, you can always automatically refill credits, so you'll never actually run out. And then we can adjust the contract at the end of next year to try and perfectly dial in the exact amount of credits that you need. And unused credits should be able to roll over into the next period, I believe. Don't quote me on that, though, because the contract part is not my specialty. That is usually worked out before I come into the picture. I do more of the technical support. So I want to couch my answer there in saying I'm not 100% sure how it works. But on server, on the self-hosted version, it is not billed by credits, which, that actually dovetails really well into your next question here. How convenient. So on server, you are billed per user. And the answer is yes, because on server, it doesn't really make sense to build with minutes because you're using your own resources. You know, we bill by minute on cloud because we are paying for the executors that are spun up in AWS. When you build in server, you're paying for those. It's on your own infrastructure. So you're paying AWS for that. It wouldn't make sense for us to charge build minutes on top of that. So instead, we just bill by user. You just get a certain number of user seats, and that's what you pay for. Okay, so I will hang out here. Oh, there we go. Another one. Is CircleCI support on cloud support self-hosted executors? So we do actually have something called runners. What runners allow you to do, they're sort of a middle ground between people who need fully on-premises solutions like server and people who can use fully managed solutions like cloud. With runners, what you can do is actually take a CircleCI runner, so the thing that actually runs the build, and run that on your own resources, but it will pipe that output to the cloud. So a really common example that people might want to use runners for is if they have something on an internal network and they don't want to connect to, they don't want to have Circle have to SSH in to like a jump host or something and then access their internal network. You could use runners and run that on a machine in your network, be able to grab whatever resources it needs. And instead of having Circle communicating into your personal network, you have the runner communicating out to Circle. So yes, that is sort of a nice little middle ground. If you were to sign up for CircleCI, the CSM or account executive that's assigned to work for you should be able to fill you in on exactly what that would look like, what that would require. But yes, it is possible to run cloud and have a few things that are running on your own self-hosted machines. Now, if you want to run everything on your self-hosted machines, you would want to use server for that. You wouldn't want runner to be 100% of your build pipeline. But if it's just the occasional thing that you need to do, or if you have very specific use cases in mind that you know you need to run in your own environment on self-hosted machines, runner's the perfect solution for that. All right, we have 1 minute left. So if anybody has any more questions, and now is the time to ask them. Hang out here for just a little bit longer and see if anything comes in. A couple more seconds here. You're very welcome. Okay, so I think I'm going to wrap it up. Thank you, everybody, for attending. Really appreciate it. I hope that you learned a little bit about CircleCI and the kinds of things that we're able to offer. I hope I got you curious or a little bit interested in learning more. And like I said, we should have resources available for you after the webinar. And I hope everybody has a wonderful rest of your day, whether it be morning or evening, wherever you are right now.